I wonder how much power this is using. What about that? Is that going to be enough for the next 2 days? Should I run my generator maybe? Is my battery going to be fully charged by the time we get there? So when I plug in, how long does it take to charge my battery? The answer to these questions and much more coming up. Hello and welcome. So today we're going to be talking about power management and power strategy for your RV. Now, if you've been watching the channel, you know that I've just recently upgraded my RV from the old lead acid batteries to a new smart lithium battery. And in the process, I learned quite a lot about how much power I use and how much power I need to be able to go off-grid for 2 days, 3 days, whatever the case may be. That includes state parks, national parks, harvest hosts, dispersed camping, and of course when you're camping off-grid, one of your most valuable resources is how much battery power you have. So today we're going to focus on battery power management and strategy. And quickly before we get started, the usual disclaimer: this video is not sponsored or paid for in any way. All of the products discussed during this video were purchased with my own money, and the opinions are entirely my own. So, over the course of this video, we're going to start out by looking at how to determine your daily power needs and how that compares to your available power in your battery bank. And I will also include a few examples from my experience. In the second section, we'll do an overview of the various lights, fans, and other devices throughout your coach and see how much power each of these consumes, and obviously then we can look at ways potentially on how we can save in our daily power usage. And in the final section, we'll look at the recharging strategy. We'll take a look at the different recharging options that are available, how effective they are, and how you can work these into your overall trip plan. Now there is a lot to cover here, so as usual I've placed the agenda up here. That agenda should also be available in the video timeline, so if you want to skip to a particular section, you can do that also. So if you've been following the channel, you'll know that I recently did an upgrade to my coach, taking out the old lead acid batteries and replacing them with lithium. And I'll place a link to that video at the end of this one if you're interested. Now, of course, the main reason for doing that upgrade was for the added battery capacity, but that wasn't the only reason. Another reason was because this was a smart lithium battery that comes with built-in Bluetooth and a really cool app that gives me real-time information about the status of my battery. Now, with my old lead acid batteries, my only source of information was up here looking at the voltage of the battery and using that information to try to guess what my remaining capacity was. But now, thanks to this app, I have the complete information available at my fingertips at any time. So you can see here I have the available battery capacity. It shows me how much power is currently being drawn or being provided to the battery, and it shows me here my remaining capacity. So this made it very easy to test exactly how much power I use in a 24-hour cycle. Now, if you don't have a smart battery like that, you do still have options open to you, the first of which being this guy, the Victron Smart Shunt. Now, the good thing about this guy is that it doesn't matter what kind of battery you have, lithium-ion, lead acid, or what configuration you have, whether a single battery or multiple batteries put together in parallel or in series, you can use one of these. And it will give you pretty much the same information that we talked about with the app for the lithium battery, but I do find that the estimation of remaining battery life is not always quite accurate. Now, the Smart Shunt costs around about $130 and it requires installation. If you don't want to spend that kind of money or do the installation, a cheaper option would be to use one of these guys. Basically, the idea would be to make sure your batteries are fully charged, then plug into shore power, but act as if you're using just your batteries only, and then see exactly what power you consume over a 24-hour period or whatever period you're measuring. The important thing to note, though, is that these things are relatively limited. I'll place a link to this one also in the video description, but this one's limited to about 1800 watts, which if you're just using battery power for normal things like lights, fans, and that type of thing, is not going to be a problem. So in my case, of course, I used the app that came with my battery, and I determined that for typical dry camping over 24 hours, I would consume around about 80 ampere hours. And that's being fairly conservative, so just using the basics, lights, fans, water pump, things like that. Now for us, the main draw on our power is the refrigerator, which in a 2020 Navion is 12 volt only. And this thing draws around about 60 to 70 watts, so around about 5.5 amps when it's running. But of course it doesn't run non-stop. During the daytime it probably runs about 50% of the time. During the night when it's cooler it runs a lot less. And so of my 80 amps that I consume during the 24-hour cycle, this is probably around about 50 amps. The rest was just lights, fans, water pump. We also used the heater briefly, which runs off propane to generate heat, but of course the fan it uses is powered by the battery. So using my app then, I determined that over the course of 24 hours, we were using around about 80 ampere hours, and that's being pretty conservative, as I said. Now my new lithium battery has a capacity of 300 amp hours. So that would give me almost 4 days of operation at that kind of capacity. But most vendors are saying that you shouldn't take your lithium battery much below 20%. So if we assume that we only have 240 amp hours, that still gives me 3 days without any kind of battery replenishment. Now, of course, we could also use our inverter, and that would allow us to run the TVs, run internet. We could even run our microwave and induction cooktop off that if we wanted to. But then, of course, we would use significantly more power, and how much power, that's something we'll look at in the next section. So, how much power do the various lights, fans, and other devices in your coach consume? That's what we want to cover in this particular section. Now, we're not going to cover everything here, and what I'll do is I'll place a table in the video description which should give you a lot more detailed information, particularly if you're a Winnebago Navion or View owner. But for now, we'll just cover the highlights. Quickly before we get started, just want to mention that when doing these measurements, I noticed that there is a considerable fluctuation in the background current, and that makes it kind of difficult to get an exact number on all of these measurements, particularly if we're dealing with a very small draw. So these numbers are just approximations. So let's start out with the lights. Now on a Winnebago Navion, most of the lights are these ceiling cans arranged in various groups of 1, 2, 3, and 4 lights. And based on the measurements I did, each of these lights running at full power is about 5 to 6 watts, which is about a 0.4 to 0.5 amp draw on your battery. So obviously if you have 2 in a group, double that, 3 in a group, triple that, and so on. As an example, in the bedroom, there are 2 lights configured on a single switch. So at full power, they are pulling around about 0.8 to 1 amp. When you enter the coach, there are 4 lights on what I've referred to as the main light group. So these together will pull around about 1.6 to 2 amps. Now, one exception seems to be these galley lights here, which is a group of 3, but together they only seem to consume around about 1 amp. So these seem to be a little bit lower powered. Now, I mentioned full power a minute ago because many of these light groups offer both a full power and a low power mode, such as the bedroom here. So right now we're in full power mode, and I can switch over to the low power mode. And in low power mode, it seems to be around about 30 to 40% of the power. So whereas in full power mode, each of these individual lights is consuming between 0.4 and 0.5 amps. If I put it in low power mode, it's definitely less than 0.2 amps per lamp. So this is definitely one good way of saving power in your coach. Now, one of the light groups that I really like in the Navion are these really cool accent lights, which as you can see run all the way across the top of the galley, all the way across the top of the bedroom, all the way across the top of the dinette, and even around the floor, and they provide a really nice accent lighting. The downside is that this light group consumes around about 30 watts or about a 2.5 amp draw, which makes it the most power hungry light in the entire coach. And unfortunately, there is only one setting, and that's full power. Now, it would be really nice to try to equip this with a low power mode, and that's something I might look into in the future. Outside, there are also a couple of lights. This main one here will draw around about 0.7 amps. And there's also the awning lights, which will draw about 0.6 amps. And finally, on the lights, if you like to read in bed, these things run around about 2 watts, which is between about 0.1 and 0.2 amps. And the nightlight mode doesn't even register. Now, when it comes to fans, there are basically 4 that we need to talk about. We're not going to discuss this one because this one will not operate unless you're plugged into shore power. So our 4 fans that we're looking at are the kitchen vent, which draws around about half an amp. Probably the most important fan in your coach, the bathroom vent, which runs at around about 1 amp. Next up is this guy, the main coach ventilation fan. Now this has a variable speed which can be set in 10% increments from 10% to 100%. At 100%, it's running around about 35 watts, which is drawing around about 2.5 amps. But at 10%, it barely registers anything, and even at 20%, it's only about 0.1 amps. So setting this to 10 or 20% is a really good way of moving air through your coach without using a lot of power. Now, the last fan we're going to talk about is the one that is used whenever you're heating your coach through the propane furnace. Now, this is a pretty power-hungry fan because it has to move the air throughout the coach, coming out of the vents like these 2 on the ceiling and located at various other locations throughout the coach. So this one runs at around about 5.5 amps, so this is definitely one to use sparingly. Now, we already talked about the fridge earlier on, which, as I mentioned, in my particular coach is a 12-volt only fridge, which runs around about 5 to 5.5 amps. Now, if you're fortunate enough to have a 3-way fridge, you might want to consider running that on propane instead of on battery. I guess that depends on which your most precious resource is. But for me, I don't really have a lot of choice. But there are a few things I can do to try to minimize how often it kicks in. Now, a couple of easy ones include not grazing when you open the fridge, but to know exactly what you're looking for and take it out. Now, of course, you don't have to be quite this extreme, but obviously knowing what you're going for before you open the door does help. Another option is to change the temperature setting. Now, the values I mentioned earlier on in terms of the 50 or so amps that I consumed in a 24-hour cycle were based on having this set to the medium setting, and this fridge gets pretty cold. So certainly an option would be to dial that back, maybe take it down a notch in temperature. And what's nice is that you can regulate the temperature for the freezer and the fridge section separately. And also there is what is called night mode, which places this in a lower power mode during the night hours. Now, I'm not exactly sure how much benefit that brings, but it's something that's certainly worth looking into. One last 12-volt device I wanted to mention was the water pump. Now this is a pretty power hungry device, taking around about 5 to 6 amps when it's running. Now of course there's not a whole lot you can do here. If you need water, you need water, and if you're in a situation where you're truly dry camping and don't have access to fresh water to refill your tank, you'll run out of water long before you run out of battery. But if you do have access to fresh water and you're refilling your tank, just be aware that this thing is pulling around about 5 to 6 amps, and even if you do this and run it at a very slow rate, yes, you're saving water, but no, you're not saving battery. It's still running at around about 5 to 6 amps. So far in this section, all of the devices that we've looked at have been devices that run directly off 12 volts. But like many coaches, my Navion is also equipped with an inverter, which allows me to run 120 volt devices also. Now, a couple of important things about inverters. Number one is, even when it's idle, even when it's not doing anything at all, your inverter will pull a certain amount of current out of your battery. In my case, it's probably somewhere between 1 and 2 amps. The other thing to mention is that inverters are not 100% efficient, probably more like 90 to 95% efficient. So if you have a device which when plugged into 120 normally draws around about 10 amps, you can expect that to draw somewhere between 10.5 and 11 amps out of your battery. Now in my coach, the inverter is a Xantrex XC2000, which will handle up to 2000 watts. So it will easily handle the microwave, the induction cooktop, and many other devices that are really high power. But to be honest, those are not the types of things that I want to run off battery power, and we'll talk a little bit more about that later on. For me, the main things I want to run off 120 volts include the TVs, internet, and any streaming devices. Now in my Navion there are 2 TVs, this one being the main TV, and I was quite surprised at how efficient this one is. It's running at around about 40-45 watts, which is drawing about 3.5 amps, which, if you recall from earlier on, isn't much more than the accent lights that I was complaining about. And I can also catch up on my favorite YouTube channel from the bedroom, and this little TV only draws around about 2 amps. Also worth mentioning, my mobile internet only draws around about 1 amp. And a streaming device like a Roku or Amazon Fire Stick draw less than 0.2 amps apiece. One last thing regarding 120 volt devices. If you have a particular device, a toaster, a coffee machine, whatever it may be, and you're wondering how much power it consumes and should you take it in your RV, you might want to also check out one of these power meters that we discussed earlier on. Now, earlier we discussed using this in order to measure how much power your RV is consuming over a certain time period. And of course, you can use it for any single device as well. Not only will it tell you how much power the device is currently consuming, you can also set it up for a certain time period, 1 hour, 1 day, whatever, and see how much it consumes during that time, and then decide whether that's a good device to be using in your RV. Now, there are many of these available. I picked up this one on Amazon, seems to work pretty well, and I'll put a link to this into the description as well. So in the previous section we talked all about the various devices that will pull energy out of your battery. In this section we're going to talk about the different devices that will put energy back into your battery, so your recharging options. Okay, let's start out talking about solar power. Now this is definitely my favorite way of putting power back into my battery. Once you have the equipment, it's completely free, it's good for the environment, and you don't have to lift a finger. As soon as the sun comes up, it goes to work putting power back into your battery. Now, what you're looking at here, I believe, is the standard configuration on a Winnebago Navion or View as of model year 2020. So you have two 100-watt flexible solar panels, which are glued to the roof in this instance. So not necessarily the best solar panel. I think we've decided that the rigid solar panels are much more efficient these days. And also gluing them to the roof, it doesn't make them as efficient as they could be because you get a lot of heat buildup. The other problem, of course, is, as you can see, is that they face directly upwards. So when the sun is low in the sky, as it is right now, you don't get a lot of charge. Now, of course, one of the problems with solar panels is you need to have good sun reaching them in order to get some power. And very often when you're camping, you have trees. And as you can see right now, the sun has disappeared behind these trees that are behind me, and I'm pretty much completely in the shade. And at this point, I'm only charging at around about 0.4, 0.5 amps. So with this particular configuration, if I were to have truly ideal conditions, so middle of summer, clear blue skies, no trees or any other kind of obstructions, I could probably harvest around about 500 to 600 watt hours during the course of a day, which is somewhere in the 40, maybe as high as 50 ampere hours, which is around about half of my daily power usage. Now, certainly I could look at upgrading this, increasing the capacity from 200 maybe to 400 watts, and also using a higher grade rigid solar panel. And with that configuration, I could probably get upwards of 1,000 watt hours, again under ideal conditions, which would actually be sufficient to cover my needs. Now, Winnebago has made the system expandable. The ZS30 solar charge controller inside the coach will handle up to 30 amps, which is close to 400 watts of solar. Now, there are 200 watts on the roof. There is actually an additional port that you can plug in and a third panel on the roof. And there is also an auxiliary solar input, which for some reason they decided to bury inside this compartment here all the way at the back. The nice thing about this one is you can connect a portable solar panel to this one, which if you're in the shade like I am right now, you can run a cable out and put it in the sun where you can still get some energy into your battery. So here we are back inside the coach. I'm now looking here at the Zamp solar charge controller, and as you can see, here's that 0.4 amps that's currently going into the battery. We still have that shadow going across the solar panels right now. If I take a look at today's total, you can see so far today we've harvested around about 23 amp hours of energy. We had some pretty good sunlight during the day. It's about 2:30 in the afternoon in early September, so the sun is fairly low in the sky, but this is a pretty good return considering. And once that main shadow has passed, we'll still get a couple of hours of harvesting, so this number should probably get up around about 30 amps, which is a pretty good return for the day. So no discussion of recharging would be complete unless we also covered shore power. Now, shore power is in most cases going to be your fastest way to recharge your battery whenever you have that opportunity. So let's plug in and see what happens. Now, I'm going to share the app with you here so you can see exactly what happens. As you can see, currently we have a residual charge from the solar. It's getting very low in the sky, and we have around about 1.5 to 2 amps still going into the battery. So let's see what happens when I plug into shore power. And as you can see, we're now charging the battery at 80 amps. So in a Winnebago Navion, the charging through shore power is handled also through the inverter. This is an inverter charger, and in this case, this is a Xantrex XC2000. Now the XC2000 will charge the battery at a maximum current of 80 amps, as we saw outside. If you have an older version, you may have the Xantrex XC1000, which will charge at a maximum current of 40 amps. Now, of course, when you're plugged into shore power, it doesn't matter what 120 volt devices you use, you're still getting that 80 amps going into the battery. So charging at 80 amps, you can imagine this charges your battery pretty quickly. In my case, I have a 300 ampere hour battery. In the unlikely event that it was completely drained, I could charge up my battery to full in just under 4 hours at that rate. But do keep in mind that most chargers, as they approach 100% battery capacity, they will slow down the charging in order to prolong the battery life. Next up, let's talk about using the generator in order to charge your battery. So before we get into the discussion, let's start up the generator, because it takes a couple of minutes before it actually starts charging the battery. Now, this is pretty much the same as plugging into shore power. It will charge your battery at 80 amps, and of course it will power all the 120 volt devices at the same time. Now, as you can see right now, it's charging at around about 74 amps, so not quite the 80 we saw before, but I believe that's simply because the battery is at 93%, so the battery itself is now limiting the charge going into it. Now, of course, similarly to shore power, you could run this for several hours and completely top off your battery, but let's be honest, who wants to run their generator that long? It's using up your propane, your diesel, your gas, whatever it runs on, and as you can hear, it's pretty loud. That's not only for you, but also for your neighbors. So let's not be that guy, right? But what I will do if I want to run a high load device like the microwave, the induction cooktop, maybe a toaster or a coffee maker, something like that, I have no problem powering up the generator for as long as I need in order to do that. And by doing so, I'm not pulling that power out of my battery, and also I get a bit of a boost that my battery is charging as long as the generator is running. Another way of charging your battery is, of course, to hit the road. So like pretty much all motor vehicles, whenever you are driving, in fact, whenever your engine is running, the alternator in your engine takes a small portion of that energy to generate electricity in order to charge your battery. But in the case of an RV, it's charging not only the chassis battery, but also your house battery. Okay, before we start, let's take a look at where we currently are. Now, I have pretty much everything turned off except the fridge back there, which is running, which is drawing around about between 5 and 6 amps. But I do have a little bit of solar coming in, probably about 2 to 3 amps. So you can see right now we're running at about minus 3.7 amps. So let's see what happens. And as you see, we are now charging the battery at around about 34-35 amps, and that was in comparison to about 3 amps that we were drawing on the system. So this is somewhere between 35 and 40 amps. So as an example, if I now set off and drive 3 hours to my next destination, that's going to put in about 100 ampere hours into my battery. There is one more recharging option that I want to talk about, and it's something of a secret weapon, if you like. This is a so-called solar generator. Now, it's not a generator, it doesn't produce any power by itself. It's basically just a big battery with a built-in inverter and solar charger and a few other electronic bells and whistles. Now, when it comes to these devices, there are many options out there. This one is from EcoFlow, and it has a capacity of just over 1 kilowatt hour, which provides me about enough power for 1 day of dry camping. Now, in addition to having a high capacity, it also has high power handling capability. So this particular one, I believe, handles up to 1800 watts, which allows you to basically plug your RV into it in the same way as you would plug into shore power. It's basically like having one of these for your battery. But in order to make sure this isn't just a one-time top-up, I also carry around a couple of these guys, portable solar panels. Now the benefit of having these portable solar panels is I can place them anywhere and direct them directly towards the sun all times of day. So unlike my roof configuration where I was pretty much limited to around about 500 to 600 watt hours in a day, on a sunny day, by moving these panels around, I can refill this battery completely. Okay, so basically I have my shore power plugged into my EcoFlow solar generator here, and I'm gonna power this on. You hear that the power has been activated on the coach. And as you can see, we are now charging at 70 amps. Now, this is exactly the same result as you would get by plugging into shore power at this point. The XC2000 inverter is capable of charging at up to 80 amps, but probably because we're around about that 90% mark on the battery, that's why you're seeing a slightly reduced charging current. So that is our video on RV battery management and strategy. Thank you so much for watching today. If you have any comments, any questions, if you wish to share your experience or expertise, or if you have any suggestions for follow-up videos or related videos, please go ahead and enter those into the comments section. I would love to hear from you. If you found today's video informative and helpful, please hit that like button, and also please consider subscribing to the channel where you'll find a lot more content around tech, travel and leisure. Thank you again for watching.